Hello, welcome to yet another video. And this video we are still on the properties. We are still on properties of matrix. So we talked about in the previous video we talked about addition and subtraction. That's what we talked about in the previous video. On this video we are talking about multiplication. So we are talking about multiplication in this video. If you are new to my channel, please don't forget to subscribe and hit the notification bell so that every time when I post a new video, you'll be alerted first. So we are talking about multiplication in this video. So how do we multiply? They say we multiply. So multiply row by column. So we multiply row by column. So that's what we multiply. So we multiply row by column. So that's how we multiply. So for example, if you have been given something like this, which is you have been given A is equal to, you have been given the entries 2, 1, 4, 3, and then B, you have been given the entries 3, 2, let me write nicely 2, so 3, 2, 1, 2. So these are the entries that have been given. So we have been given A and B, so and then they have said we have to A, B. Simply means multiplication, or in other terms, it's same as A times B. It's the same. So this is what we're doing. So first of all, you get the matrices. So matrix A is 2, 1, 4, and 3, and matrix B is, we have 3, 2, 2, 1. So that's what we have. These are the two matrices that we have. So by ordering them, we'll say it's a 2 by 1 matrix. Even this one, it's a 2 by 2, sorry, it's a 2 by 2, and this one is a 2 by 2. Okay, so those are the 2 by 2 matrix. So what makes these two matrices to be multiplied is, number one, this number here and that number there. So if these two numbers, they are the same, then these two matrices can be multiplied. But if these two numbers, they are different, then these matrices cannot be multiplied. And then the answer will be a 2 by 2 matrix. The answer comes from these two and also these two. So it has to be a 2 by 2 matrix. But these two and these two, they're telling us to say these two matrices can be multiplied. So that's how it is. So multiply, remember, multiply row by column. That's what we multiply. So this is a row, and then we multiply by this column. Again, the same row multiplied by the other column. So again, we come to this row, and then we multiply by the column, and then the same row multiplied by column. So rows this side, columns this side, rows this side, columns this side. So that's how we multiply. So we start. So we're going to say open, then we say 2 times 3. So we're going to say 2 times 3. So I'll write 2, let me say 2 times 3, and then plus, so I'll put these in brackets, and then plus, and then it's a row by column, so it's 4 times 2, so 4 times 2, so in brackets. Then that is a row by column. Again, there's the same row, another column beside, so it's 2 times 1, so it's 2. We don't have to add here because we have started with another row, so we don't have to add, or another column I mean. So we are on this row and then we are going to the another column, so it's 2 times 1, so it's 2 times 1 in brackets plus 4 times 2, so 4 times 2. We are done those row and column. So row by column, this row by the row by column, and then another row, the same row by the other column. So this is it. Then we come down another row by column, row by column. So 1 multiplied by 3, which is 1 multiplied by 3 in brackets, and then plus open bracket 3 multiplied by 2, so it's 3 multiplied by 2, of course, and then open another row, another column, the same row, column, so 1 multiplied by 1, so 1 times 1, close, and then plus open, which is 3 multiplied by 2, so it is 3 times 2. That's how we multiply. So it's a row by column, row by column, row by column, down row by column the other side. So that's what we do. So now we start. I'll write this side. So I'll write this side, which is 2 times 2, 2 times 3, 2 times 3, it gives us 6, plus 4 times 2, it gives us 8, so 8 there. 2 times 1, it gives us 2, plus 4 times 2, it gives us 8, so 8 there. Okay, again down, 3 times 1, it gives us 3, plus 3 times 2, it gives us 6, 1 times 1, it's 1, and then plus, which is 3 times 2, it gives us 6, so that's what we have. And then from there, 6 plus 8, it gives us 6 plus 8, it's 13, it's 14 I mean, sorry, so it's 14, 2 plus 8, it's 10, and then 3 plus 6, it is 9, 1 plus 6, it's 7. So this is the matrix that we have. So when you look at this matrix, it's a 2 by 2 matrix. So that's what we do on that one. Let me give another example. So another example, say C, we have this kind of matrix, it is 2 and 1, and then D, we have this kind of matrix, which is 3 and 4. Those are the two matrices that we have. Quite nicely, yep. So these are the two matrices, and then we'll say C times Z D. So this is what we have. So we get C, which is 2 1 matrix times, so we can put terms or we can put terms there, but we have to know that it's multiplication, so 3 4. That's what we have. Now for these two matrices, we're going to order them. So this is a 2 by 1 matrix, and this is a 1 by 2 matrix. So 1 row, 2 columns, two columns, one row, or two rows I mean, and one column. So this number here, I said this number here and this number here is what is telling us if these two matrices can be multiplied or not. So these two matrices can be multiplied because there's one here and one there, so they can be multiplied. So how do you multiply? Row by column, row by column. So say it's so the answer will give us it's a 2 by 2 matrix, remember. So 2 multiplied by 3, so say 2 times 3, that's a row. So row multiplied by column, there's no any other number down here on this column, so we move on, row again multiplied by column. So we say 2 times 4, we put them in bracket. Here we don't have to put addition. Why? It's because this row has multiplied by this column, this just one single column, and this another row multiplied by the other column. So there is nothing here. So there's these two, they are in different columns. They are in different columns, so that's the reason why we don't have to put in a positive here, which is addition. We come again down, row multiplied by column, so it's 1 times 3, so 1 times 3, so we have got 1 times 3, and then this side 1 times 4, so 1 times 4, another row and another column. And then we start multiplying. So 2 times that 3, it's 6, it gives us 6, and then 2 times 4, it's 8, 1 times 3, it's 3, 1 times 4, it's 4. So these are the ones that we have. So we have got those ones. So that's the answer there. Let me give another one this side. So another one, we have got A. Let's say we have got a matrix 1 and 4, or 2 and 4, sorry. So 2 and 4, and then we have got B. We have 2 and 3. So these are the two matrices that we have been given. So A times B, or A multiplied by B. So A multiplied by B. So A is this matrix, so we get that matrix, which is 2, which has got entries 2 and 4, and then B, so multiply by B, we have got those 2 and 3 entries. So 3. So first we order them, so it's this a 2 by 1 matrix, and this is also a 2 by 1 matrix. So there's 1, 2 rows, 1 column, 1, 2 rows, 1 column. So we check the numbers, so say this one and that one. So these two numbers are different, so we can see that they're different. So which simply means that these two matrices cannot be multiplied. So it simply means that they cannot be multiplied. They cannot be multiplied. So these two matrices cannot be multiplied. That's how it is. Why? It's because these two, they are different. So this is 1 and this is 2, so they cannot be multiplied. So even if we were to multiply row by column, it cannot be multiplied because it can't give us this number, which is a 2 and 1. So that's the reason why it cannot be multiplied. Let me give another example. Another example is we have got C, which is 2, and then we have got D, and this is 2, sorry, that's 2. Okay, so I've got these two matrices, and then we say C times D, or it says C and D. So multiplication, so we're multiplying, we are still multiplying, so we get the matrix, which is C. So 3, 4, we get the matrix, which is D. So 2, 1, and then 4, 2. So these are the two matrices that we have. So this one is a 1 multiplied by 2 matrix, we order it, so 1 multiplied by 2 matrix, and this one is a 2 by 2 matrix. Okay, so we check out this number and that number, these numbers which are in between, at the middle. So 2 and 2, meaning these two matrices can be multiplied. So let's start multiplying. It's a row multiplied by column, so row multiplied by column. So 3 multiplied by 2, so the answer, remember the answer will be a 1 by 2 matrix. So 3 multiplied by 2, so it gives us 3 times 2 in bracket, and then 4 times 1, so it's plus, we are adding here because we are still in the same column. So 4 times 4 times 1. Okay, and then row multiplied by column. So we have gone to the another column here. We haven't changed the row, so we are still maintaining the same row, and then we have gone to the other column. So we are not going to put addition here. So 3 multiplied by 4, so we are going to say 3 times 4. So that's what we have, plus 4 multiplied by 2, so it's 4 multiplied by 2. That's what we have. So these are the things that we have, these are the matrix that we have. Okay, so the fact that we have got this such matrix, we are going to say, we're going to start multiplying. So we're going to say 3 times 2, it gives us 6, so say 6, plus 4 times 1, it's 4, and then 3 multiplied by 4, it's 12, plus 8, 2 times 4, it gives us 8. Okay, so we have multiplied, we add now. So when we add 6 times the 6 plus 4, it's 10, it gives us 10. 12 times 8, it gives us 20. So we have got 20 there. Okay, so that's what we have. So that's the final answer. So now this final answer, you find that this final answer, let me say it's a 1 by 2 matrix. This 2 which comes from here, it's this one, and this one here, it's this one. So it's a 2 by 1, it's a 1 by 2 matrix. So because these two matrices can be multiplied, so that's how we multiply matrices. So please don't forget to subscribe to my channel, and don't forget to hit the notification bell, so that every time when I post a video, you'll be